Hey all, so you made it through a big section all on proofs, and we're going to jump back now a little bit and add in some more vocabulary involving sets. And of course, we're going to end up back with proofs again, as you can probably imagine, but we're going to introduce a couple of new concepts here over the next coming weeks as we look into chapter 11. So get yourself ready for notes, and we're going to get started. There's two problem sets here. I recommend watching the video in its entirety and just working through the problem sets at the pace that you like. We're going to start by talking about relations here. So we're going to get started with our vocabulary. Now, a relation, which is often just going to be represented with a capital letter because it is a set. So a relation, and we'll use R, on a set, and that set is usually called A, is a subset of the product of A cross A. So what that means is that all the elements of R are X, Y, where X and Y are elements of A. And it can be written as an ordered pair, or you'll also see written like this as if it's like an operation. Both ways are fine. So let's look at a couple examples of relations. So let A be the set 1, 2, 3. Write the relations R below. So for part A, it says R is the relation that expresses that X and Y have the same parity. Now, when I write these out, sometimes it's helpful for me to say, oh, well, if it has the same parity, that means that we are looking at even numbers, so in this case just 2, or odd numbers, which in this case is 1 and 3. So then the relation R here, remember, is the set of ordered pairs. So the even set is pretty straightforward, 2, 2, because you can absolutely have the same number, the same element for the X and Y position. So then we have 1, 1 and 3, 3. You'll also have the pairs 1, 3 since they have the same parity, and 3, 1 since order here is important and you want to include both. Here's another relation. R expresses that X is less than or equal to Y. So sometimes with these ones I like to set up, okay, well, what is my X term and what are my possible Y terms? So X has to be less than or equal to, so Y could be 1. I could also have 1 and then 2, since 2 is greater than 1, and 1, 3. And that's where I'm going to end because we're only talking about the set A, 1, 2, 3. Next, 2 and 2. So, because we're having or equal to. Then we could also have 2, 3. And then the last one, 3, 3. And while this is a little bit of an odd way to write the list, it's a way to help stay organized. And this is equal to the relation R. Now, there's a couple ways that we can illustrate relations. One would be in a diagram like this. So a relation R on the set A is illustrated on the left. Write the sets A and R. So A is generally the one that is easiest to start with because A is just a list of the elements that we see here. So in this case, A is the set. We see the element A, B, C, and D. So that's what A is. Now R is going to be each of these lines represents one element of R, where the start of the line, where here is the X value, and it goes towards, so you have to follow the arrows, towards the Y value. So this point here, A is the X, going to B is Y. So A, B is one of the elements of R. You might also see one that forms a circle. It's starting at A, it comes back to A if I follow the arrow direction. So that's going to be one of the points that has the same for X and Y. The next one, as I see B going here to C, following that direction. So B to C, And then the last one is C to A, and that's our relation. You'll notice here, not every point of the original set is going to show up in a relation, and that's just fine. Now, the other way you might see this illustrated is in a graph, especially if we're talking about natural numbers, real numbers, integers. So, a relation R on the set A is illustrated on the left here. Write the sets A and R. So in this case, A is the real numbers, and hopefully you remember that the coordinate plane can also be expressed as the real numbers times the real numbers, and occasionally it's written as R squared as well. So what we can say here about R, and I'm going to use set builder notation because in this shaded region there are infinite points, and that's what I'm trying to write for. So I will say X and Y, where X and Y are in the real numbers, or I can just say where X, Y is in the set R squared. And here I'm looking at a linear inequality, so I will say where Y is less than, because we have a dotted line here and it's shaded below that line. And then I'll write in the equation for that line. I'm just going to use 2 points that I see on the line. So in this case, I see it has -4 here and -1, +2 there. So the slope is up 2 over 3x. And it doesn't quite go through at an integer here, but using my slope, I can say +2 2/3 as the y-intercept. So you'll also have relations written in set builder notation. Let me know if you have questions on any of the new vocabulary in Chapter 11, Section 1, and nominate any homework problems you're stuck on in the forms attached to the assignments. Talk to you later.